Welcome to Bulgaria. This is
Thank
your
you.
third time in Bulgaria for the
Yes,
last
I'm feeling
year
like
and a half.
I'm feeling like a native already.
Native here at St. Constantine and Helena. You're attending a conference on genome architecture and dynamics.
Yes.
And I wonder, how do you find it?
Oh, the conference has been fantastic. We managed to bring to Bulgaria some of the world's leading scientists in what is probably one of the most exciting fields of applying physics to biological systems, and it's been a great learning experience for me listening to all these people and getting a chance to interact, and also having all these students who get a chance to really learn about the subject matter from the experts. So I think it's been a great success.
Great. So we have a large number of Bulgarian scientists here. How do you find the Bulgarian science?
Well, I find that there are very interesting projects going on. Of course, they're a little bit limited by funding, which is perhaps not surprising. But within those constraints, I think there's some very exciting work going on in Bulgaria. This is one of the fields of science, the field of chromatin genome organization, which is well represented in Bulgaria with some excellent people at the Academy of Sciences working in this area. So it's very appropriate that we have this topic as the focus of our conference. And I think it's been mutually beneficial for the Bulgarian scientists to be integrated in the rest of the community working on this exciting topic.
So yeah, that's actually been great. We have a lot of young people here as well, both from Bulgaria, from other countries. So the whole community here is kind of biologists and physicists, and you yourself work on cancer, and you're a physicist, theoretical physicist.
Correct.
So what can theoretical physicists bring to cancer?
Well, that's a very good question, which I keep getting asked by lots of cancer biologists. And the answer is that cancer is a very complicated subject, and different cancers are different from each other, different patients are different from each other, and it's very hard to just gather data in a vacuum and try to understand, generally speaking, what are some of the most critical issues. So physics offers a set of tools for constructing, in the end of the day, simplified models, but models that have the power to really cut through all the complexities of the data and try to find at least some unifying ideas. So for example, in our own work, one of the unifying ideas we found is that cancer cells can often become less specialized than the tissues in which they came from. So a cancer cell that started, let's say, being a lung cell can actually become more plastic, more capable of surviving, and those are the cells that really are the dangerous ones, because at the end of the day, you die of cancer if you metastasize. Metastasize means that cells from one part of your body need to be able to grow in a different part of your body, and it's only those cells that have sort of been going backwards in this specialization pathway, have become more generalist, are able to do that. And that's an idea that came out of our theoretical calculations, which was sort of hidden in quite a bit of the cancer data. So it's now pretty much accepted idea, because one can show how this arises and why this is interesting, but I think it was not an insight that was easy to get by just looking at the complicated data.
So how do you see the possibility of your research influencing cancer cure, or cancer at least perhaps maintenance?
Yeah, so when I give talks about cancer, I say, I ask at the end, have we made progress? And the answer at the scientific level, I think, is definitely yes. And at the clinical level, I say, well, maybe. And I think the first area in which there might be some useful outcome is not so much in the treatment, but more in the prognosis. We know that many cancers, if left alone, actually will not particularly turn dangerous. This is especially true of something like prostate cancer in men who are over the age of 60 or 70, that most of the time the cancer will grow slowly. It will not really cause any life-threatening harm over the rest of the life of the patient. Right now we can't predict which of those cancers are, so if we can understand better what are the cells that really do give rise to metastasis, we have a better chance of predicting which patients need aggressive therapy and which perhaps don't, which in the case of prostate cancer, aggressive therapy is not very life-enhancing for the patient. So I think that might be the first direction. Eventually we might hope to have therapies that can specifically attack the cells that give rise to metastases. But I think that's a harder task because there you have to worry about side effects. You have to worry about really how you get the drugs to specifically attack those cells. Those cells are different than the majority of the cancer cells. So I think that might come, but I think the first goal would be really better predictive capability.
That's extremely important, of course. And here at the conference, can you tell us something that was most exciting to you that so far you have heard?
Yes, many people that I've been talking to over the last few years have been focused really on the structural aspects of the DNA and genome with amazing progress, both experimentally in terms of measurements and also in terms of theoretical ideas that now really have helped us understand what those measurements really mean. But the part that's been less tackled by the physics community is what it all means for the actual functionality of the cell. We know that structure has to be important for just packaging of DNA in the nucleus, but we don't really know how that packaging process really then affects cells expressing genes, being able to undergo transitions from one type to the other, and just functioning in its day-to-day operation. I think for the first time we've sort of brought together people who are not only looking at structure, but other people who are looking more at function, and I think there's some confluence of ideas that really now one might be able to make progress on that over the next few years.
Fantastic. So at the end, what you would like to see improved in Bulgaria during your next trip?
Well, that's an interesting question. I don't know. Let's see. The weather here is pretty much perfect, except a couple of rainy days. So we can always
improve on that.
Improve on that. The food is pretty good. Maybe the beds in the hotel could be a little bit better. Really nothing. I mean, it's sort of. I wish. I hope that this conference is the first of many that basically lead eventually to Bulgaria being just a regular, normal part of science as it's done in the modern world, and I think it really has enabled a large step in that direction. So that's what I really look forward to over the years in the future, where it won't anymore be surprising to have a meeting in Bulgaria, where it won't anymore be surprising to have large Bulgarian delegations at other international meetings.
Well, thank you very much, Professor Levine.
Sure. Thank you.